Alright, so we're going to look at some composite function problems. Let's see, whoops. The symbols that you're going to see when we're doing problems like this, it's going to look like this. You're going to have a function name, in this case I'm using g, and you're going to have another function inside of that function, in this case f, and the way we would read this, we would say g of f of x. Okay. You don't have to use g and f though. You could use other letters. You could use a function named h and I don't know, t, and put a y in there if you wanted to. And the way you'd read this is h of t of y. Okay, so that's what you can expect to see as we're doing these problems here. Alright, so let's take a look here at our first problem. For this first problem, we are going to have two functions. If I can get my pen to work. Alright, so we're going to say f of x, which is equal to x minus 2, and g of x, which is equal to x squared. So those are our two functions, and we want to find g of f of negative 2. That's what I'm looking for right here. Alright, so this is how this works. We're going to take the innermost function, f, and you figure that out first. So you take f of negative 2, and I'm told over here, right here, that f of x equals x minus 2. So I'm going to put negative 2 in x's spot and then subtract 2. When I do this, I get negative 4. That's the value. So now I want to figure out my outermost function, and when I do this, I'm talking about g. That's on the outermost function. That's right here. I figure out g of negative 4. I take this answer that I just got and I fill that in the parentheses. Now my function g says take whatever's in the parentheses and square it. So I'm going to square negative 4. I make sure that I put parentheses around it because I'm substituting the negative 4 in for the x, and that is worth 16. So my final answer for this problem, g of f of negative 2 is equal to 16. The last number that I get, this 16 right here, is the answer to the entire composition of functions problem. Alright, let's do another problem here. Maybe I'll try to use some different colors so it's easier to see what's going on. So let's see. Let's use the same two functions actually. We'll write them in different colors. So we have f, which is x minus 2. We have the function g, which is x squared again. And what we're trying to find this time, oops, let me see something here real quick. Yeah, okay. What we're trying to find this time is f of g of negative 5. So I'm going to put f of, and then we'll use red for g of negative 5. Get fancy here. Alright, so that's what I'm looking to find. So I start out with the innermost function, which is g. So I have to figure out what g of negative 5 is. And it says that I should square what I'm substituting in for x, so that gives me 25. And now I want to work my way to the outside, work with f. So I'm going to take, and I want to figure out f of 25. And I note I'm using 25 because that's what g of negative 5 was worth. And that's what goes right there, g of negative 5. So I'm putting it right there, 25. Alright, so now I want to figure out what this is worth. So I put in 25 in place of x, and then I subtract 2 because that's what it's telling me to do right there. And so I have f of 25 is equal to 23. My final answer then is going to be f of g of negative 5 is equal to 23. Alright, let's do a third problem here. This time we have two new functions. We're going to say that we have f of x, which is equal to 2x plus 3. We have g of x, which is equal to 3x squared. And we'll use a different color here. I want to find what g of f of 3 is worth. Alright, so just with the other problems, I'm going to start at the innermost function, which is f. So I figure out what f of 3 is worth first. And my function f says that I take 2 times 3, that's what it says to do right there, and then add 3 to it. Alright, so f of 3 is equal to, what is that, 6 plus 3? So f of 3 is equal to 9. Alright, so now we take this answer that we just got and we plug it into the outermost function, which in this case is g. So I'm going to say g of 9, that's going right there, right, is equal to, now remember I'm using g, so I have to take 3, and in place of the x I'm going to fill in the 9 that I just got, and I'm going to square it, and that becomes 3 times 81 if you're following the order of operations. So g of 9 is equal to 243. 81 times 3 is 243. So my final answer here, I would say that g of f of 3 is equal to 243. Alright, let's keep going. Let's do a few more. Alright, let's see here. Let's say we have two functions, g of x, which is equal to 3x plus 2, and f of x, so let's call it h of x, just to show that we don't have to use f all the time. It's going to be a fraction, x minus 2 over 3, and we are trying to find f of g of negative b. Uh-oh. We put a number in this parenthesis, or a variable in the parentheses instead of a number. We're in trouble. Okay, so start on the inside. G of negative b is on the inside. So I need to take 3 times negative b, that goes in place of the x, and then add a 2. And that gives me negative 3b plus 2 when I multiply. Now, I can't do anything else because those two terms aren't like terms, so I'm going to have to leave it like that. I wrote f over here, didn't I? Nice. Let's erase that. That doesn't work, does it? Let's see. Will this work? I'm just going to cross this out. That'd be the easiest thing to do. Alright, let's try this. That's no good. Let's call this h of g of negative b. I forgot I changed my function name. Okay, anyways, now we have to work with h. So we have h. We're going to put in what we just got. And now we have to use our function h. So in for x goes the negative 3b plus 2. It says subtract 2 right there, so I'm going to subtract 2. And then it says divide by 3, so I do that. Alright, let's see what happens here. Well, I can drop the parentheses. So plus 2 minus 2 over 3. And hopefully you see that the 2 minus the 2, those cancel out. So I'm left with negative 3b over 3. and I can even divide now. 3 divided by 3 is 1. So I'm left with my final answer here of h of negative 3b plus 2 is equal to negative b. So I would say h of g of negative b is equal to negative b. Alright, we're going to do one more problem with the same two functions. Let's see here. Let's do g of f of a. Let's see here. We'll say, well, g of h of a, since I changed the name. G of h of a. Let's figure out what that's worth. So we're going to start on the inside, h of a. And h says that we substitute in the a right there for the x, subtract 2, and then divide by 3. There's nothing we can do with that. We're stuck with a minus 2 over 3. Okay. Now we move to our outer function, g. The g's on the outside right there. And we plug in what we just got, which was a minus 2 over 3. And g tells us that we're going to take and multiply 3 times what we sub in for x, which is a big old nasty fraction, and then we add 2 to it. Okay. Something I noticed right here, I'm taking 3 over 1 times a minus 2 over 3. I'm going to cross cancel. Make those ones. That makes it real nice for me. So when I do that, I'm left with g of a minus 2 over 3 is equal to a minus 2, it's coming from right there, plus 2, and minus 2 and plus 2, they cancel each other out. So that's all equal to a, all that business right there. So my final answer is g of h of a is equal to a. That's what I got right there. Alright, so remember, when we're doing composition of function problems, you start on the inside, you evaluate the function for whatever value is in the parentheses, you take the answer that you get and you substitute that into the outermost function and you evaluate it again, and then whatever you get that time is your final answer. Alright.